Okay, guys, now I have given you a handout. Today we are just gonna, I should say, change the gear. Start on working on some of the key functions that you are just gonna encounter over and over and over again. And the next test, which is gonna be, I should say, on I think November 25th.
Okay, that's soon. Why are we saying that?
25th.
Why are you reading?
Because we just had one and then 2 weeks before we had
And November 25th, guys.
3 weeks from now. That's so close.
Matthew,
That's what I said.
Elisa. And then this part of the lesson is going to be a very interesting part for the test because as you're going to see right now, we are changing gear a little bit. We are working with the things which are going to make more sense. Now, I'm just going to start. You see that I have, you see one expression today, 4x plus 12. You see it 4 times in different formats. 2 of them are here. 2 of them are over there, and if you cannot see this from the back, I'm just gonna when I'm done over there, I'm just gonna erase from here, put it back there. And the handouts that we got is gonna be I should say a point of reference until I should say next week. Then
You have class next week?
no, until the week after that. Now, look at this one. I'm just gonna start with this function. Look at this. You have a function over there. And we have been working with this. You take a look, you step back, you take a look, you see that f of x is 4x plus 12. But when you look at this, you wonder if there is going to be something wrong. Or, I mean, for example, if that function is going to always behave normally. But when you look at this function over here, I come back to this one in just a couple of minutes, you look at the functions which we have, which worked out also on a couple of sessions before the test, you see that yes, I can see there is something, the same expression, which happened over here, and now the same expression shows up in the basement of this structure, which if you remember from the past, it reminds you of something, that thing should not go to 0. Then that becomes a kind of that alert, a fire hazard. Then you remember from the thing that we discussed before, we said 4x plus 12 should not be 0. Then we say, let's solve it. Get back to that question?
No.
Yes. Then we say, let's solve it. Daniel, to see that, I think if you shut down your laptop, you have more focus then. If you please shut it down. Yes, thank you. And now you see that if you take it to 0, you see that in that case, we learned that x can be minus 3, which that thing, it tells you if you put minus 3 into the basement of this house, it causes the fire. And that's what we have to avoid it. Then as a result, we said that 4x plus 12 should not be equal to 0, which means that x should not be minus 3. Now I'm going to focus here. For the people who said that, why do we need to find the restrictions when we're working with the rational expressions? Now you're going to see why we are doing this. First of all, the first thing that we do is this. Let's make it more fancy with those different colors. You see that? What do we do here? Then we define, I should say, the domain of this function. We said that the domain of f of x can be written as this. We say that, oh, wait a minute. We can have every x welcomed into this function except x, which is going to be minus 3. Because if I put minus 3 there, it causes a fire. Then let's put it aside, exclude it. And you remember that. We learned it all before the summative test. We can write it like this. We say that the x, which represents the variable for that function, it can be anything. It means that it can be any real numbers. However, x cannot be equal to minus 3. Fantastic. Thank you, Lisa. Now, and that becomes, I should say, our domain. Now, yes, Dave.
Wait, actually, I'm you're probably going to solve it.
Oh, you're saying? Yeah.
But like, with the questions here that you're giving us, I noticed that like you're solving for x plus 12. So what we do is for both sides, and then both of them are the domain.
Oh no, we are going to get to that in 5 minutes. If if you're looking at the handout. Thanks. Very, very advanced question. I like that. Thank you. Now, guys, look at this. Look at this one. Lucas and Elisa. But look at this. Go back to the same thing that we started. You see the same expression, but here is just standing alone. It's not going to hurt anyone. And you ask yourself, is that function is a well-behaved function? You say, yes, if I even put -3 in there, f of x becomes 0, and it's not going to hurt anyone. It's not dangerous. Then what do I say? For this type of function, we say that, okay, then the domain of this function, it has no restriction. And then, because we say that x, the domain is a set, that all the variables in that function, all of them belongs to the all real numbers. There is no exception. Yes?
What's the difference between that expression and the, when we're finding the domain for that, we don't set it equal to 0? We just say
You mean this one?
Yeah.
Look at that, Lucas. We only said this should not be 0. Look at this one as a house. If this is the roof, if this is a basement, you never like to have a fire in your basement. But look at this one. It's just walking on the street and it doesn't matter. Then that's why we say that the functions, this is the first type of functions that we are going to learn in level 3. That we say that these functions, we just call them linear, we said that they are defined everywhere.
Is that non-linear?
This one, we say that rational expression, we do not call it non-linear.
It's just because it's not under something.
That's right. It is not on the basement, and as Elisa said, this is not under anything that says, okay, it has no restriction. It's free to go everywhere it wants. Yes, Daniel? Yes.
What defines a real number? Like what? Like
What defines? Alex asked a very good question. What defines a real number? Any numbers that we can think of, positive, negative, fraction, anything, they are real numbers. However, when you go to university, first or second year, they're going to talk about complex or imaginary number, which is going to be a very interesting part of the math.
does that include E?
E includes the real numbers.
E is every real number.
That's right. But good question. I'm going to talk more of the complex number. Ask me at the end of the class. Okay. Now, any questions on this? Because those are the things that we taught. We have seen them before. It was just a review, Daniel. Huh? Yes?
No, I'm good.
Awesome. Now, I'm just going to go back to this function.
I got everything.
I think if I write here, it's going to be quite awkward for the people at the back.
It will be awkward.
I'm just going to take this. Oscar probably cannot see this.
Mine, oh mine.
Let me erase this.
So you can just write on the whiteboard thing. That's not a whiteboard. What is it?
Okay. Let me erase this part.
Right.
Now. Okay, now let's take that one there and let's start it from here. We say that f of x, it's 4x plus 12. I call that the functions for the rainy days. I call that the square root of umbrella. Look at this one. The same. Huh?
I thought umbrella too.
Yeah. Look at this. Look at this one, guys. The same phrase, the same expression that we had, 4x plus 12. However, look at this. It is not under the base, but this is under the umbrella of something. And now you are asking yourself, what are going to be the restrictions? Because any functions that you are going to see from now on, I give you functions, I draw your functions, for example, Matthew, you grab it, and you ask, oh, this is a function, what is the restrictions for it? The first thing that we do is to find the restriction. Now, I'm going to do the same thing, find the restrictions for this function. Then what do? I look at that, there is one expression underneath these square roots or the umbrella. You remember that from, I should say, from the math. We have said that all the time. For example, what is that number? If I say A is a real number, that A is the square root of 9, what do you say is going to be the answer? Plus 9. It is plus 3. That's right. However, if I say b is equal to the square root of minus 9,
You can't do it. Error.
why?
There's minus.
That's right. There is no answer for this because we say that there is a minus number under the umbrella sign. Yes. Yes, yes, please. Then because there is a minus number under this square bracket, then we say that there is, oh, we got the error. The computer, I should say, broke down. It collapsed because there is a number which is negative in there. I'm going to use the same concept and again look back at the same expression which I had. I had 4x plus 12. And I say, okay, this expression cannot be negative. And that's how it defines my restriction. Because it's square root of minus 9. Under the umbrella, you cannot find any negative number, and you got the error. Also the same thing here. You cannot have any negative number beneath. Then what does it mean? It means that the 4x plus 12 should not be negative. It should be positive. How can I show it's going to be positive? Yes.
You would write the domain with that, but put
The greater sign, huh?
Yeah.
Yes, that's right. As I said, I just say that, okay, it has to be greater than 0. Why? Because if you remember, Daniel, when we talked about the x-axis, imagine, guys, this is the x-axis on the top. Anything on the right side, which is greater than 0, is positive. Anything less than that is negative. Then as a result, in order to define the restriction for this function, I say, okay, this one has to be, the thing which is under the umbrella has to be always positive. But wait a minute, what does it tell you? It means that 4x plus 12, it has to be positive. What does it tell you? I need someone to interpret it. It's not easy to understand.
Is that it could be all of, or
Yes.
that x can be any positive real number.
X can be any positive number? You're almost there, but there is a trick. Guys, look at this. It's as if something like that. You say that instead of x, you are going to buy an apple. And it says that you ask the cashier, how much is one apple? The cashier tells you it's going to be 4 times. Apple times 4 plus 12, it has to be greater than 0. You say, tell that again, what do you mean? I need to know the apple, not 4 times of the apple. Then the question is that, how much is the apple itself? Then as a result, you have to solve this expression. Now it's going to be our new lesson. We call that linear inequality.
Is there another way to write apple? Is that to draw an apple?
The apple draws something else.
I know, right now.
Guys, welcome to the new class then now. Now we're going to solve the linear inequalities. Now, I'm going to erase this part. I'm going to erase this part, and now, guys, everyone listen right now. Everyone, Matthew, listen carefully, because this part is a new lesson. So far, we were reading some stuff from the past. Now that we know that we have to solve this, in order to understand what is the x, now we enter the concept which is called linear inequalities. In the handout which I have given to you, the first page, this is for today's work. We come back to the first page a little bit later. The second page, solving linear inequalities. You learn these concepts, then you can work with any, I should say, functions like this. Now, look at this. I'm just going to rewrite it here. For x plus 12, we said that because of the restriction that it involves, it has to be positive. Now, how to solve it? Look at this. For just a moment, guys, imagine that this symbol, which it says that greater than 0, If I want to solve it, what does it mean? For example, look at this. I'm just going to write it with a different color to highlight this for you. Imagine for a second, I'm going to solve this, but in the form of the equation. 4x plus 12 equals to 0 instead of the greater 0. How to solve this? I know that the key, yes, Lucas.
I'm sorry,
No, no,
I have a question. I was
no,
gonna
just say,
so to solve it, you bring 12 to the other side, plus minus 12. X equals minus 12 divided by 4. X equals minus 3.
Fantastic, thanks. As Lucas said, the strategy for this, that guys, to isolate the x. Keep x somewhere as a prisoner, isolated, then express the rest by it. What does it mean? It means that Daniel, for example, what do? You take 12 to the other side. You get 4x equals to minus 12. Guys, look at it. I call this step number 1. And for step number 2, Daniel, for step number 2, look at this. I divide both sides by 4, which becomes x equals to minus 3. I call it step number 2. Now, guys, take a mental image, take a mental picture of the thing which we did. I love how Daniel is taking that image, blinking. Really, you are taking that image. Now, I'm going to erase it. Then I'm going to do the same true strategy with respect to this inequality, but with a very big trap. There is a trap. When you come to this inequality, there is a huge deal in front of you. You have to avoid it. And look at this. Step number 1 and step number 2, all of them refer that you have to isolate the x. Now, I'm going to just focus on this inequality. Guys, look at this. First of all, as Lucas said, I'm going to isolate the x, but I'm going to take 12. Imagine that it was equality. I take 12 to the other side. With the equality, Matthew, with the equality. Sorry, what?
You're just asking for a calculator.
Oh, no, you do not need a calculator.
What does equality mean?
Equal means equal sign.
Oh, like for, okay.
Yes. Guys, listen, Daniel, Robert, Matthew, look at this. Now I take 12 to the other side, then I get 4x. Still, look at the direction of the inequality. Is it still there? But I put minus 12. Exactly, I treat it as if it was a kind of an equal sign. Now, the next step, it was step number 1. Step number 2, what is this? As what we did for, let's say, equal sign, we divide both sides by 4. Then it becomes x greater. Still look at the direction of the inequality. It seems as if, look at this, it is like a fish. It's like the fish is swallowing that x. Guys, don't laugh at my drawing, because in 2 minutes I'm going to tell you why that fish is going to get crazy. What? That fish is going to turn into a shark. Look at this. This is a fish now. In 2 minutes, it's coming into a shark. Look at this. Now, I'm going to erase for a moment this beautiful fish minus its first. Now, I divide both sides by 4, then I get minus 12 divided by 4, which is essentially like this. X is greater than minus 3. Yes?
Do we have to show the step?
The step?
Do we have to show the step?
Yeah, the step it needs to be shown, like exactly how you solve an equation. However, guys, I was going to tell you that this, I should say, fish is going to turn into a shark. And how is that happening? Oh my God, this class is a little bit funny because I need this stuff, but I have to erase it and just write something different. Now, guys, everyone, any questions for this part? Step 1?
No.
Look at that. This inequality seems somehow similar to solving an equation. Solving an equation. And now, I was trying to find, before I just show you how that fish is going to turn into either shark. Before I forget, let me finish this equation, this problem, then I'll show you how that fish is turning into a shark. We were trying to find the restriction, then domain of this square root function. I had to find a restriction to say that 4x plus 12, guys, has to be positive. Then I looked into it as an inequality. Because look at that, as we said, when you say A equals to B, this is equality. This, we call them equal, A equals to B. But when we say A is greater than B, or A is less than B, or A is greater or equal than B, you have had these signs before, huh? These are all what? Inequalities. Now, we just learned that we have to solve an inequality. It was a very basic one. We are going to have more challenging examples in the next 10 minutes. Now, I just find the domain of this function. What was the domain now? I know the domain is this. I said that the only restriction which I have is that whatever comes under the umbrella, it has to be positive, because we do not have the square root of minus 9. Then I solve it like an equation. It tells me x has to be greater than minus 3. Yes? Now, it defines, I should say, my domain. Then it means that the domain of function equals, as usual, we show it as a set. X belongs to the all real numbers. Guys, however, my friends, x, now it has a range, not a single number. We said that x has to be greater than minus 3. Now it becomes the domain. Now it shows a range. But, any questions so far?
No.
But guys, there is a problem sometimes with the math, and it becomes sometimes too much numbers. Then, for example, I just wear glasses, and when I look at too much math equations, it makes my eyes ache. Now, sometimes you have to visualize some stuff that it makes it easier to understand it. When we work with these inequalities, we show them on the x-axis as a kind of a visualization method. Look at this. Look at this for the same thing that we had. X equals to, it's too low for the others. Let me bring it here. Look at this. I had to erase the problem itself to continue. That's a disaster. That's really a disaster. Look at this. This is the x-axis. And now I show the origin on the x-axis, and now I constructed a GPS. Everyone knows what is a GPS?
Yeah.
You find the directions. Anywhere you construct the x-axis or y-axis, it becomes your GPS. It gives you the direction, the address. Now, I have the x-axis with the origin. I localize minus 3 legs. Look at this point, minus 3. Now, I just want to show that the thing over here, which it says x greater than minus 3, show that on the x-axis. How to do that? Look at this. I show minus 3, and I'm very good, guys. You cannot believe that. I'm so good in drawing a circle. Wow. Isn't that nice? And I draw that circle. It means that minus 3 is selected, is chosen. But now, from minus 3, if, for example, Simon, if you are standing at minus 3, how many directions you can walk along the x-axis? How many directions do you have?
3.
3 directions.
No, only one. You can go from -3 until infinity.
You mean from negative to this way?
No, negative infinity.
To here?
Yeah.
You mean if you want to show this?
That's why I think it's greater than.
Greater than.
Yes. Guys, look at that. How to resolve it? We have some very interesting ideas. If imagine Simone is standing here at -3, she can either go that direction or go that direction. But I'm going to ask Simone, you cannot go to both directions just at once. You have to choose. You say, okay, I'm going to choose a direction which is greater than x. Any x which I pick is greater than -3. Then say, I Simone, no worries. For example, if you walk towards this direction, always x is getting bigger and bigger and bigger. Because we say x is bigger than -3, we show a range like this. And I'm going to highlight it like this.
draw a big circle, or is that just so you can make it easier for us?
It's a circle, but this one I just a little bit exaggerated to be big. It means that, yes.
Can we just put arrows?
Arrows, you have to do the arrows like this.
Yeah.
But you have to highlight this area to show that this belongs to the range. Now, guys, and there is one thing that it becomes like a convention, and we follow this. I could have said, guys, x, for x is greater or equal than -12, which means that x is greater than equal -12/4, which again it means that x is greater or equal than -3. Then if it shows that -3 is also included, then what do? You come to
How can we change it to greater or equal then? Isn't it just greater than?
greater or equal. You can have equal or greater, because if this is equal, it means that then under the square root it becomes 0, which is still acceptable.
We can write either one.
Yes, but it doesn't do not. I just wanted to just put that the equal
Okay.
to tell everyone if this is equal, you have to fill the circle.
Okay.
So what does that mean? How can you just greater
Greater than is just it's greater than is not.
Is greater, and at the same time -3 is included.
Yeah, but I don't understand the sign with the equal.
You mean this one?
Yeah, I don't understand that.
It means greater, but if you put this one, it means that also this is equal. At the same time, it's bigger, and at the same time, it's equal to -3. Means -3 is also included.
Oh.
Yes, Daniel. You have a question, Daniel?
I was just asking if you would tell us the right timeline for the test.
26th of November, 25th.
Are you
November.
going to tell us to do the line?
Oh, no, I thought you mean the date. Yes, do the line. It's the visualization of the intervals.
Okay, so we don't have to?
Yeah, you have to.
Oh, yeah.
Yes.
You have to watch this.
Yeah, sure, please. Now, guys, if everybody understood how to solve a linear inequality, any questions on to solve any linear inequality?
No.
No? Then please go to this handout.
Already finished.
No, I have one more function to talk about. I'll do this. You can have, I should say, 1 minute break. You can just stand up, do some stretching. Oh, Lex couldn't wait for the break. Yes. Janaya, Daphne, Simone, Janaya, guys, look at everyone. Now, the thing which we are going to do today is going to be right now, it turns out to be somehow something like a magic. Now, I'm going to turn a fish into a shark. And this is going to be one of the memorable tricks you're going to see. Watch carefully.
Do I hear voices, or am I just imagining things? Where's the fish?
Look at this. No worries, guys. Everyone, please look at this. It's going to be one of the most... I'm a David Copperfield in the TFS right now. Look at this. Look at this. Matthew, look at this. Guys, look at this inequality. Look at this inequality. I call this inequality because, as you can see, there are these two phrases on the left and on the right, they are not equal with the equal sign. They are unequal. Now, look at what's going to happen. I'm going to solve it. But how, Daphne? I do step number 1, means to isolate x on one side of the equation. If this is the equal sign, you have no problem to solve it. You say that, okay, if this is the equal sign, I take, for example, 12 over there, take x here, for example, then I solve it. Now, look at this, what's going to happen. I say that, okay, I'm going to isolate the x. I spend a couple of seconds with myself, then I decide to keep x on this side, and I take the numbers on the other side. Then what means that? I have 5x.
Minus 8x.
That's right, minus 8x, because it comes to the other side, and it changes the number, is less than, I'm getting close to the favorite treat in the math, is less than, and I take 12 to the other side, becomes negative, huh? Becomes minus 12 minus 30. Now, I do some kind of minor simplification. 5x minus 8x becomes how much? 3x. Minus 3x. Now, you are going to see this chart in just a couple of seconds. I have this equal sign, minus 12 minus 30.
Minus 42.
Minus 42. Now, look at this, guys. You are going to see this chart right now. First of all, guys, please listen. Look at this. Look at this beautiful fish. Look at this charming, enchanting fish. Guys, listen. Matthew, Lucas. Now look at this one. Guys, every eye's on the board. This is very important. Now look at this. Now, the next step for me is this. I know that minus 3x is less than minus 42. And you see that the fish is swallowing minus 42 because it has opened his eye. Not eye, jaw. Now, I'm going to divide both sides by minus 3 to isolate x. If I do that, what do I get? I get x minus 42 over 3. How much do you get? 14. Now, but look at this. Now the magic is here. This minus sign that you used to divide, Trevor, this minus sign that you used, guys, to divide both sides by that, it turns the fish into a shark, and the fish comes back at you to swallow you. And now we will look at this. The direction it changes. Yes.
So the direction changes when there's the negative?
That's right. The direction changes when you divide the inequality by something minus or multiply that by something minus. The fish which was swallowing 42, which it says that, okay, 42 is bigger, I'm hungry, I'm going to swallow this. But when you divide it by something negative, it changes back, it swallows you.
And then you divide by something positive.
That's right. If you divide by something positive, it remains the same.
I have a question.
Yes.
Why?
Why? That's a good question.
Best question of you.
Look at that. Daphne, look at that. If, for example, imagine that. If you have 3x is less than 42, Daphne, if you divide it by 3, still x is going to be smaller than 42 over 3 because 14. However, when it becomes negative, Daphne, when it becomes negative, when you divide it by the negative, it changes the direction because right now the x itself in absolute value terms is becoming greater than 14. And when I talk about the fourth function here, which we have absolute value terms, you understand it much better. But remember, when you divide by something negative, that thing now, because this is negative, this is smaller. But when you divide it on along the x-axis, in its absolute terms, becomes bigger than the previous one. You have to wait maybe next 10 minutes when I solve the fourth function. You understand why there. Yes, Matthew.
Was it just a coincidence that x was minus 3?
It could be anything but minus.
No, I mean because the other one was also minus 3.
Oh yes, it's a coincidence, really. Now, guys, look at this. Now I'm just gonna visualize it. I show the x-axis, and I put the 0 over there. I see 14 here, and that's the number 14. I'm gonna show it on the axis. Then what do? I just open a circle. 14 is not included because it's not equal to 14, but x is greater than 14, which it means that if Simone is standing there, she's going to decide to go that direction, because that direction shows every x is bigger than 14. Yes, Elisa?
Yeah.
If you have, guys, any question now, ask me, then we just move to do some practice on your own. Now, everyone, you see that tree? Yes, Jenna?
How do you know that it is equal to what?
Because I didn't initially put that equal to. If it was equal to also there, Janaya, then everything remains this way.
But even when it's equal sign is the other one.
Yeah, because that's how we define it. It depends on the question that you get. Sometimes they say equal, sometimes they say that's bigger than. Make sense? It depends who designed the question for what purpose. Sometimes they say that, okay, solve it with the greater and equal sign. Then you can get some all along the way. Awesome. Now, guys, please do question number 1, 2, and 3 on this handout. Then after that, just move on to work with some interesting function. I call it walnut. Yes. And Lex knows what I'm talking about. Guys, please everyone take your seat back. Now, let's put all those things together. Let's start with the first one. The first one is this. We have 2x minus 8 is greater than 4x plus 12. Now, look at this. It somehow seems, let's see if we have to use the trick to turn the fish into a shark. We decide, guys, to keep x on the left and keep the numerical values on the right. It depends on you. If you're going to do this, the first thing is that you take 4x, you take this out, bring it to the other side, and it becomes minus 4x. Then you have 2x minus 4x is greater than, and you take 8 minus 8 to the other side, becomes positive 8. Then you get 12 plus 8. So far, so good, everyone? Yes? Now, the next step, I'm going to simplify this. 2x minus 4x, how much is that? Minus 2x. Fantastic. Is it still greater than 20? Now, guys, be very careful now here. Look at this one. I'm going to divide both sides now. Because what is the strategy? The strategy is to isolate the x, to get its coefficient 1. In order to do that, I'm going to divide both sides by what?
Minus 2.
Minus 2. And now you see that. When you do that, you turn the fish into a shark and it comes back at you. Then becomes x. It changes the direction. If it was facing that direction, because now this is divided by minus 2, it becomes that direction. 20 over 2, which it means that x is less than 10.
Isn't it minus 10 because we're divided by minus 2? 20 divided
Oh
by
yes, minus 10. That's right. Minus 2, minus 2. Now, you want to also visualize it. You put the x-axis there. You put the 0 over there. You highlight the point, which is minus 10. And you know, guys, look at this one. Everyone, please listen. X is less than minus 10. If you are standing anywhere, for example, it is me standing over there, and I do not know where to go, but I know something. If I walk towards this direction, X is getting bigger and bigger. If I walk towards this direction, X getting smaller and smaller and smaller. Now I'm looking for the X's that they are smaller than minus 10. It means that if minus 10 is here, I'm looking for those ones who are smaller than minus 10. Does it mean that I'm going to the left or right? That's right. And that becomes my answer. Any questions on this? Everyone is happy? Happy, happy, happy? Nice. Guys, please write it. I'm just going to erase it to go to the next one. Write and erase. Next, how was your answer? The same? Where did you go wrong?
I divided those by 2. I got x minus 4 over, and I also divided that by 4. Came x plus 3. And I took the negative 4.
Remember, always isolate it to make it on one side x, the other side numbers. Before dividing anything. That was a good thing. Lucas! Now, go back to the next one.
Yeah.
Now, guys, please everyone quiet. Matthew. Now, the second one. Yes, sure.
Do we have to draw the line?
Yes, for the test they ask you, show that on the line. Right?
What was actually meant for, like, what was actually less than that. Greater than less than
Okay, guys, please quiet. Look at us. Now, the next one, we do not have much time. Let's finish everything. Minus 4, 5 minus 3x is less than 2 times 3x plus 8. Now, look at this one. How to solve this? Guys, always remember, the strategy is this, to isolate x simo, one side, and take everything to the other side. But before doing this, look at this. I'm being annoyed now because of these two numbers. Minus 4, which it means that it has to be first multiplied to this term, and also 2, which has to be first goes inside these two terms before doing anything. Yes, Elisa? Makes sense? Now, look at this one as a key. You have to be that open these doors before you just use this. If you do that, minus 4 times 5, how much you get? Minus 20. Minus 4 times minus 3x. Thank you. Plus 12x. I keep the direction like this. 2 times 3x. Plus 16. Fantastic. Now, let's look at this part. And Elisa, this part is the place. Now we have to isolate the x. This is always my preference to keep x on the left side. It means that still I have the direction of inequality pointing to the right. I keep x as that direction. I have 12x on the left. I take 6x crossing that inequality sign going there becomes how much?
Minus 6x.
That's right, thank you. And I take minus 12, 20 to the other side, becomes how much? That's right.
Very good.
Now, for the next one, 12x minus 6x, how much is that? 6x. Still, the direction is this, 36.
No.
Guys, please listen. Matthew,
You stole my pen.
brother, guys, we don't have much time. Please listen. Now, I divide both sides by a positive number, which is 6. Then how much is going to be the x?
The direction is going to stay the same and it's going to be 6.
That's right. The direction doesn't change because you divide it by a positive number. And x has to be less than 6. Now, you wonder, how should you show that on the x-axis? You have 0, you have 6. Guys, today I hear lots of talking. Please stop it.
If you put the x's on a different side, you get a different answer.
Yeah.
Yes.
No, if you mean take it to the other side?
Yes.
No.
Yeah, because
Who
that's-
says yes? I
No,
bet
no,
you.
I know because I just did it. Because you're dividing minus 6, which is a negative. So
I'm
you
going to do it with a
divide.
different color. Let's see what happens. That's a good practice. That's a good practice. Everyone listen. That's a good practice. I'm going to use a different color, redo my work, but instead of keeping x on the left, take x to the right. Let's see what happens. I'm just going to start from this. I take x to the other side, means that I have 6x
Minus 12.
minus 12x on that side. And I take 16, Kate, and everyone listen, 16 to the other side. Becomes minus 20 minus 16, correct?
Correct.
Now, from here, Kate, look at this. I have minus 36 is less than how much? 6x minus 12.
Minus 6. And you're dividing something by a minus, which means you change the sign.
That's
So
right.
So you got a different answer.
I love the answer. No, you do not get the right answer. Look at this.
Yeah, you do get a different answer.
No. Guys, look at this.
I know,
Kate,
but there
Kate.
is a different sign.
Hey, Lisa, listen. Minus 6, you divide it by this. You change the direction. From here, it changes to this. You have x, and you have 6. How is that different from this?
The sign.
X is less than 6, x is less than 6.
Okay, it's just written the opposite way.
We got the same answer. Kate, do you notice how? Do you notice it's the same answer?
You read that on a test, is it right
No,
though?
that's not the same answer. Thank
yeah,
you.
Huh?
It's the same answer. It's not the same answer.
Look at this. That's how I did it. I know.
It's not the same answer. It's not.
Look, Kate, listen.
It's just a fluke. Normally it's not the same answer. It's like it's inverted.
It's inverted about the same answer. We say that x less than 6,
How's that different?
x less than 6. The same.
The same. X is always less than
The
6.
bottom like it. Yeah, but then once you get to more complex questions, you realize that it's really important to keep it on the other side.
No, it doesn't matter. You choose base over you want.
When you do questions like this one, it's really important to keep the X on the right side.
We go to that one. But I hope that you're convinced now. We got the same answer.
Yeah.
Awesome. Now, let's do the third one. Guys, if I hear talking more, guys, I'm going to be a very bad marker. I'm just going to be very strict. I'm going to be very strict.
Isn't that blackmail? Speaking Matthew.
Now, let's go. How much time do we have? 20 minutes. Oh, that clock is wrong. Okay, now look at this one.
Can we do the one after this? Or?
Sure. If you please nobody talks, we finish everything.
Guys, stop talking.
Okay, now, as the one which we did before, I look at this one. It's very annoying to have something here, which is 3. I multiply both sides by 3. Why? Look at this. Guys, if A is less than B, you can multiply that to alpha. For example, the number n. N is still this if n is positive. What does it mean? It means that I multiply both sides to 3, then becomes x minus 2 divided by 3. This is 3. It is positive, doesn't change this one. 3 times 2x minus 2. Then what does it get? It becomes x minus 2. 3 here and 3 here. They cancel out. I still keep the same thing. I take 3 inside. Becomes 6x minus 6. I take every x's to the left, which it means that I have x minus 6x less than minus 6.
Oh, no, you get it. It's minus 2x minus 3. It's 2x minus 3 in the question.
X minus 3?
Yeah.
Oh,
I
thanks.
have eyes like an eagle.
Thank you.
No, it can't.
It becomes minus 9 plus 2. X minus 6x, how much is that?
It's 5. Minus 5x.
Minus 5x. Minus 9 plus 2.
Minus 7.
Minus 7. Guys, look at this. I'm going to divide both sides by something which is negative, Chloe. And now if I do this... Oh, sorry. Now, x... Guys, and that's the result. I divide both sides by minus 5, then I have to change the direction. Sandra, sorry, just all the time. Sometimes I look at myself. I'm so bad with the names. Sometimes I look at myself, I cannot remember even my own name. Look at this, and now that's the answer. Guys, I'm gonna finish the last one on the next page.
You just do it for good luck. So I can see your work.
Yeah, sure. You just let me do that on the board, as everyone knows. I'm gonna erase this one, solve the next.
So when you reverse the sign, it still keeps the equal. When you reverse the sign for that, it still keeps the equal number, right?
That's right. We do not change the symbol, we only change the direction.
And it still keeps the.
That's right.
That's right, lad.
I wanted to say so true. Everyone. Now, look at this. This is the last one. Seems a little bit trickier than the others. Guys, oh my God.
I'm trying to focus.
Guys, look at this. Now, this one is a little bit trickier. Why? Because you see that you have x here, which is somewhere is squeezed. It's sand. They call that sandwiched between two numbers. You have two unequal signs. Really, there's a theorem. This is called sandwich theory. It's sandwich. It's like the hot dog between two pieces of bread. Look at this. Now, how to solve it? The strategy is always to isolate x1 there. I do not have it anywhere, but I have it here. What do? I keep 2x here, and I look at 7 here. I subtract 7 from everywhere. It means that I have 2x plus 7 minus 7. However, I have these symbols. I have minus 5. I have 11. I know that I have to impact minus 7 on all sides.
Why?
Because otherwise, imagine you have A, for example, equals to B. If you add something to somewhere, you have to add to the same sign. And that's exactly like this. But what is the purpose of that? You see that if I do this, I have 7 minus 7, they vanish. Then I have minus 5, minus 7, how much is that?
Minus 12.
Minus 12. I have 2x plus 7 minus 7.
4.
They cancel out.
4.
And it becomes 4. Now, look at this now. I have almost there to isolate x. But I have a coefficient. That's right. If I divide every side by 2, then the coefficient of the x becomes 1, and that's what I intended for. Then it means that if I do this, and I notice that 2 is a positive number, if that's the case, it becomes minus 12. Divided by 2 is less than x is less than 4 divided by 2. At the end, you see that x is going to be between minus 6 and 2.
Then the final answer, do we have to solve that again?
Guys, the very last thing before we leave, and I want to show that on the x-axis. This is the x-axis, and you please continue with the rest of the homework. This is the origin here, and I locate these two numbers, which is minus 6 and 2. I have 2 plus 2 here, and I have minus 6. I know x is between these two numbers.
2 arrows.
That's right. Then I just pick up 2 circles and simply I connect them.
That makes sense.
And that becomes the answer as an interval for this equation. But remember, if it was equal or less than, you have to fill one of those circles.
Thank you, Mr.
No worries, guys. Enjoy the rest of the day.